Brown eye. Brown eyes are the ones that helped us evolve as a species. Imagine our early ancestors running after an antelope in the burning sun and sweat pouring into their eyes. They didn't have glasses, hats, or any other protection. Suddenly, a blinding flash and the sun was burning their eyes. For a split second, everything disappeared, and then all they saw was a streak of dust from their dinner. This wasn't because it vanished, but because their vision broke down under the harsh light. Without food, they were signing their own death sentence right then. But there was a group that could see, and it wasn't because of luck, but because of their eye color. That's how the crushing evolutionary advantage began. Somewhere near the equator, brown eyes gave the first humans a superpower because they looked at the horizon with eyes made for fighting and survival. Their eyes were dark, intensely saturated with melanin, out of necessity. Melanina acted like a natural shield. While light eyes scattered light into visual chaos, brown eyes dampened it like a shield designed for bright Sunday. They were opaque and better prepared for intense light than other colors. Those who saw better survived. This ancient trick still works, because today over 70% of people in the world have this built-in protection in their genes. Without them, we'd be blind in harsh light, and on the savannah, blindness didn't just mean losing sight, it meant death. There was no chance involved, just brutal selection. In the sun, the difference between hunter and prey came down to seconds. Brown eyes reacted 0.3 seconds faster than light eyes. That's less than a blink, but it was enough for your ancestors to survive and for your lighter-eyed cousins to become dinner. If it weren't for brown eyes, maybe today animals would be telling stories about those strange, slow-running monkeys who disappeared because they couldn't see danger through the sun's glare. Brown eyes aren't rare, but they are a living relic from hundreds of thousands of years ago. Blue eye. Blue eyes are a contradiction. 10,000 years ago in northern Europe, snow lay for 9 months a year. The sun shone for sometimes an hour, maybe 2. This was a nightmare for people with dark eyes. Their eyes were made for harsh sun, and in the new conditions they went blind, got lost, and died of hunger. But a mutation appeared: blue eyes. Blue eyes allowed them to see better in twilight, and against a white background. Hunters with such eyes spotted reindeer, rabbits, and tracks in the snow that others didn't notice. Whoever saw the game came back with meat, and whoever didn't died of hunger. That's why blue eyes survived in northern Europe. It was an advantage that decided life here. But blue eyes are a pure lie. There's nothing blue in them, not a gram of blue pigment. Yet everyone calls them that. When a newborn opens their eyes and that mesmerizing blue appears, everyone freezes. But what you see isn't color, and we should say, look, what a beautiful Tyndall effect. Blue eyes are transparent. They have no pigment or specific shade. Light entering the eye scatters in its layers, and only part of it returns outside. What you see is just an illusion, an optical trick. This is similar to when we say the sky is blue, but that's actually Rayleigh scattering, not the color blue. Every person with blue eyes, and there are over 640 million of them, comes from the same mutation from 6 to 10,000 years ago, somewhere in the Black Sea region. A certain European had a defect in the OCA2 gene. This error in the code reduced melanin production. Before the eye absorbed light after the mutation, it began to scatter it. All blue-eyed people have a common ancestor. Today, blue-eyed people are only 8% of the population. Scientists predict that soon this error will become a rarity, and everyone will have brown eyes again. But beware, blue eyes age and fade over time, because with age they can become cloudy. Some take on a steel shade, others deceptively turn green. This is melanin, which finally changes its mind and starts to accumulate in the iris. Green eye. Green eyes shouldn't exist. They are rare, found in only about 2% of the world's population. That's fewer than people with red hair, and rarer than a mutation giving a 6th finger on the hand. And yet green eyes exist. Green eyes are a side effect of physics and chemistry. Green eyes are not pigment. They are a reaction and the right conditions for them to form. Too much melanin, and you have brown eyes. And if there's too little melanin, you have blue eyes that scatter light. You also need lipochrome, a special yellowish pigment that gives a yellowish tint and colors the reflected light. Add to that natural light scattering, and we get an impossible color, which is a green illusion that appears only with ideal balance. However, green eyes are not stable. A minimal change in pigment, and the green disappears. Green eyes change depending on the light and conditions. In the sun, they are bright in the shade, they are dark, and indoors they look different than outdoors. No one is born with green eyes, because this color often develops in the first months or years of life when pigment production in the eye stabilizes. Hazel eye. Hazel eyes are a true biological phenomenon of adaptation. Yesterday they were green and today they are golden. You stand by the window and they turn brown, and when you enter a blue room, they become olive. Hazel eyes do not reflect light like blue ones, nor do they dampen it and protect like brown ones. That's why they are perfectly adapted to changes and do not lose visual stability. Biologically, they are characterized by a medium level of melanin, not too much to make the eye dark, and not too little for the light to scatter. Hazel eyes are extremely sensitive to changes in light, temperature, surroundings, and even emotions. They are affected even by the color of clothes or the angle of light, which means that hazel eyes actively react to all stimuli in real time. When pupils dilate or blood circulation changes, the color of the iris may look different. When you get excited, the green in them explodes, and when you are calm, they take on warm tones. When you are scared, a coolness appears as if something has darkened them from within. Some scientists try to push them into the light brown category, others into green. But they don't fit anywhere permanently because hazel eyes are not a specific color. Only about 5% of the world's population has hazel eyes. Amber eye. Amber eyes look like they don't belong to a human. You see this color in wolves, tigers, or owls because it's their natural weapon and warning. However, less than 5% of people in the world have this color, and most don't even know that's what this color island. People confuse them with hazel or light brown until the right light hits, and then you see the difference. The secret to amber eyes is lipochrome, a pigment you encounter more often in animals. But in humans, it can accumulate in the iris with minimal or zero presence of melanin. Without the blue scattering effect, you get true amber. Amber eyes do not change and have no shades. Research shows that amber eye color can cause a tension reaction in people looking at those with this color. Gray eye. Gray eyes are rare. Less than 3% of people in the world have them. They don't sparkle or change color. Gray eyes are not just a color, but a structure, because they have the least amount of melanin of all colors, even less than blue. It is this lack of pigment that causes light in the iris to scatter in a very specific way, creating a cool, steel, or ash shade. Instead of reflecting it in a warm or vibrant tone, they blur it. Red eye. Red eyes are not eyes reddened from fatigue, but red eyes really exist. True red or pink eyes appear when the iris lacks melanin. Unfortunately, in extreme cases of ocular albinism, the iris has no pigment that absorbs or scatters light. This makes the blood vessels behind the eye partially visible. When light passes through the iris, it doesn't reflect color, but blood. The result can be a faint red tint, especially in strong light. Depending on the angle of light and the structure of the eye, they may also appear purple or lavender. Although extremely rare, these colors exist. In true albinism, the redness is more pronounced and scientifically explained. These people usually have reduced visual acuity and need constant sun protection as the lack of pigment does not block UV rays. Black eye. Black eyes are terrifying. Science says they don't exist, but that's not true. Black eyes don't have black pigment in them. It's such a deep brown that it absorbs almost all light. This is the result of extreme melanin saturation. Such a high concentration means that almost no light is reflected. In the rarest cases, as in aniridia, a rare genetic defect, the iris does not develop at all or disappears. The entire eye looks like a black hole, the pupil does not close, and light enters uncontrollably. Heterochromia. Heterochromia is a joke of nature and occurs in less than 1% of the population. One eye is light and the other is dark. In most people, the body distributes melanin symmetrically in both irises. If the gene responsible for melanin production and distribution has an error in its code, a variation appears and one eye has less melanin and the other has more. The error can be inherited from parents or be a new mutation. There are 3 types of heterochromia. Complete heterochromia, where one eye is different from the other. Partial heterochromia, where a fragment of the iris changes shade like a light scar. And central heterochromia, where 2 colors appear in one and only one eye. People with heterochromia see the same as others. Ring. The eye ring around the iris is called the Kayser-Fleischer ring. This is not an eye color, but a medical warning and a danger. The ring is the result of copper accumulation in the eye at the edges of the iris caused by Wilson's disease. This is a rare genetic disorder that prevents the body from properly removing excess copper. Copper accumulates in various organs not only in the eyes, but also in the liver or brain, leading to serious health problems. The accumulation of copper begins gradually, and in the initial stages is visible only during special examinations, but in advanced cases, it is visible to the naked eye. Although it does not affect vision itself, it indicates a serious problem. If you notice a golden glint in someone's eyes, it may be a signal requiring urgent medical attention.